hours. This is Carlos Rodriguez Delgado, and this is my C++ final part 3 and final part. In this video, I want to explain file input and output, streams, and serialization in C++. Like another other videos that I made, I want to keep the presentation beginner friendly and try to explain everything step by step, just in case I need to go back to this video and understand these topics. These topics are extremely important in programming because most real-world programs need to save and load information. For example, games need to save player progress, apps save settings, websites store user information, and of course programs often read data from files. And let's just imagine that programs could not save information. Then that means that every time you close the program, all the data will disappear. For example, a game will lose your progress, a document editor will lose your files, and apps would just forget your settings. This would make software almost unusable by any user. Programs solve this problem by using files. Files allow programs to store information permanently. And today I want to explain what a input-output file means, what streams are, how programs write data into files, how programs read data from files, and what serialization means. Then I would also demonstrate everything using a simple C++ program. And I feel like by the end of this presentation, we should all have basic understanding of how programs save and load information using files. First, I want us all to understand what an input-output file means. The letters I and O stand for input and output. Input means the data that is being entered into the program, and output means the data leaving the program. For example, typing on a keyboard is input. Moving a mouse is input. Reading from a file is input. On the other hand, printing to the screen is output, playing a sound is output, and writing data into a file is output. So file, input, and output means reading information from files and writing information into files, which this allows programs to store information permanently. Without file I/O, programs would lose all their information after closing, which is one of the reasons why input and output files is one of the most important topics in programming. I feel like almost every real-world application uses files in some way. For example, just like talked about in the beginning, games save your progress, browsers save your history, music app, for example, saves playlists, an operating system, of course, store system, settings, and files. Even simple programs often use files. Now, I want to talk about a little bit about streams. A stream is basically a flow of data. You can imagine a stream like water moving through a pipe. Instead of water flowing, data flows. Streams move data from one place to another. For example, data can move from the keyboard into the program, from program to the screen, from a file into the program, or from program into a file. In this case, C++ uses streams for input and output. One common example that we've seen before, especially when kind of similar when we open a C++ console app, shows cout hello, which this does, it sends data from the program to the screen, and that is an output stream. Another example is cin, number. In this case, this sends data from the keyboard into the program, and it is an input stream. File streams work the same way. Data can move from the program into a file or from a file into the program. And I just want to mention that there are different types of streams in C++. The two main important ones in this program are offstream and ifstream. Offstream means output file stream. It writes data into files. Ifstream means input file stream. It reads data from files. The word stream is important because it describes how data flows through the program. Now let's take a look at our header files. The first include statement is iostream. In this case, it allows us to use cout and cin, which are standard input and output tools in C++. The next include statement we have right here, it would be fstream, which is the main library used for file handling. The word fstream stands for file stream, and this library also allows the program to create files, open files, write files, and read files. Without this library, we would not be able to work with files in C++. Then we have string, which it allows us to use the string data type. Strings are also used for storing text like names and sentences. Now, let's take a look at the student class that we have right here. This class stores information about a student. The student has a name, an age, and a GPA. The name uses a string, the age uses an integer, and the GPA uses a float. This class is intentionally simple because I just want to focus this presentation in the file handling. Later in the program, we are going to save this object's data into a file. Then we're going to read the data back into another object, which this demonstrates serialization. Now let's talk about the serialization. To be honest, the first time I heard serialization, it sounded complicated, but I know that the basic idea is simple. Serialization means converting data into a format that can be stored or transferred. Usually what this means is to saving data into files or sending data across a network. For example, it can be saving a game, saving a document, storing user accounts, or sending information between computers. All of these use serialization. In this example, we serialize the student object. We take the student's object's data, which is their name, age, and GPA, and save them inside a text file. Later, we deserialize the data. Now you might ask yourself, what is deserialization? This basically means reading the stored data back into the program. So, in other words, serialization means saving. Deserialization means loading. Even though this example is simple, real software systems use this same basic idea, just in a more complex environment. For example, let's take a look here at our object creation. This is our first student object. The object is called S1. Then we assign values to the object. The student's name is John. The age is 20. The GPA is 3.8. And this object now contains the information we want to save into the file. I would like to point right here in line 28, 27 to offstream, in which we're gonna create an output file stream. The variable name in this case is outFile, and the file name is student.txt. And something to point out that is really important is that if the file does not exist already, the program is going to create it automatically. And if the file already exists, then the old contents may be overridden. The keyword on this, it's offstream, means the output file stream, which this stream sends the data from the program into the file. Now, let's talk about a little about this line 30, to check if the file opens successfully, and then we look at our variable. What this does is it checks if the file has opened successfully, which is really important because sometimes files fail to open. For example, the file path might be incorrect, the file could be locked, or the program might not have the permission to open that file. I think that good programs check for errors whenever possible. If the file opens correctly, then the program continues. Otherwise, the program prints an error message. Now, now, um, we're gonna write the student information into this file, which we're gonna do right here. This works very similarly to Cout. The difference is that instead of printing to the screen, the data goes into the file. First, we write the student name, then we're gonna write the age, and then we're gonna write the GPA. This is gonna be called the insertion operator, which inserts data into the stream. The end L creates a new line, so the file should look like this: John 20 3.8. Each value appears in a separate line. And after writing the data, we close the file. Closing the file is really important because, and that is happening right here, by out file dot close. Because closing the file is really important because it makes sure that all the data is properly saved. It also frees systems like resources. And I believe that good programmers always remember to close files after using them. Now, let's run the program for the first time. The program should create the file and save the student information. Let's run the program. Okay, now let's take a look if we can open that program. And right here, this is the output file, the text file that we were talking about just a couple minutes ago. Now, we just saw by opening the file, we saw that John 20 3.8 each separated into a different line, which shows that the data was successfully written into the file. The program serialized the object data, which means that the information is now stored permanently inside of the file. Even if the program closes, the life of the file still exists. Now, let's move on to the reading section. Right here what it says in file. This specifically creates an input file stream. The variable name is going to be in file. The keyword right here, it's going to be if stream, which means input file stream. This stream allows data to move from the file into the program instead of just sending the data into the file. Which now we will be receiving data from this file. And then now at this moment, we can create another student's object. Which is going to be over here and student S2. As we can see, this object starts empty, but we are going to load the file data into this object. Now, I would like us all to take a look at this line, at line 58, where it says get line, parentheses in file, comma, S2 name. I want to quickly explain what this does. What this does is that it reads the first line from the file, and then the first line contains the student name, which we use right here, get line, because names, of course, are strings, and get line reads an entire line of text. After this line runs, S2 name contains John. Now, let's talk about the extraction operator. In this case, we're going to read the age and the GPA, which that's going to be done right here. And then, of course, this is our extraction operator, which in this case is it's extracting the data from the string. So the age is read from the file and the GPA is read from the file. Now the student object contains all saved information, which this is deserialization. The program again is loaded to the stored data back into the memory. And then finally, we print the student information to the screen right here at the end, where we have cout, name, and then it names all the other variables, which in this case was C2 name, cout age, C2 age, cout GPA, C2 GPA. This proves the program to successfully read the file. The data was not only saved, but it was loaded, and it also displayed correctly. Now, I'm going to run the full program again one more time, and this time I want us to pay attention to the entire process, which is create the object, writing the file, closing the file, reopening the file, reading the data, and displaying the information. And now, let's run the program again. So this is our output. Now, let's take a look at our output file, which is right here. And now if we go back, I just wanted to give a quick summary about everything. In this case, input and output files, which means reading and writing into files. Input, of course, means the data entering the program. Output means data leaving the program. And streams are flows of data. In this program, offstream wrote data into the file, and ifstream write data from the file. What we also learned about serialization is that serialization means converting object data into a format that can be stored or transferred. In this example, we serialize the student object by saving the name, the age, and the GPA inside a text file. Then we had to deserialize the data by loading it back into another object, which means that the file handling was extremely important because real world programs constantly save and load information without the files. For example, in this case, not just in this case, but in the real world cases, games would not be able to save our progress. Applications would not could not save settings, and also programs will lose their data every time that we're closed. That is why files I/O and serialization are very important topics in C++ programming. Now, I want to talk just a little bit more about programming that I used in the real world, uh, because I am personally, well, I have only programmed in this class, but I always thought that program was really interesting, and I knew that the possibilities were endless. So I really enjoyed this class, and I want to just keep talking a little bit more about this topic. I know that files are everywhere in software development and everything. Just like mentioned before, that almost in every application uses files in some type of way. Um, for example, my music, um, music apps like saving like your playlists, and program saving like user settings. For imagine, for example, like let's imagine if Google Chrome forgot all of your bookmarks every time you close it. Or like for example, imagine if a game deleted your progress every time you exited. Then this would make the software extremely frustrating to use because programs solve this problem by um, storing information inside of the files, because files allow information to remain saved even after the program closes, which this is called persistent storage. I believe that persistent storage means that the data stays saved permanently until the user deletes it. Without persistent storage, programs would not only remember information temporarily while running, but files would also allow programs to share that information. For example, one program can create a file and then another program can read that file, which is one of the reasons why files are so useful. And something that I want to talk about, that I've heard confusion from people is the difference between RAM and, for example, now that we're talking about files and file storage. So when a program runs, the variables are stored in RAM, and RAM stands for Random Access Memory. RAM is a temporary memory, which this means that when the program closes, the RAM is cleared. So, if a program only stores information in variables, the data disappears after the program ends. For example, in our program that we did today, the student object only exits while the program is running. Once the program closes, the object disappears from the memory. That is why files are so important, because files allow information to survive even after the program ends. So RAM is temporary storage, but files are permanent storage. Programs help load the data from a file into RAM. It changes the data, and then they also save the updated data back into the file, which this process is constantly seen in real software applications. Now, for example, for in this case for our output file, we used a text file, which in the file that we created, which it was one of them, a text file. I believe that text files are just simple files that store readable text. In this case, it was just the name, the age, and the GPA, which the output read to us. That was John 20, and their GPA was 2.8. I feel like these are pretty useful because humans can just open and read the file easily, and text files are useful because they are simple and easy to debug. However, some programs use binary files instead. Binary files are not, like, for example, human readable, like these are, because they store information directly as bytes. Binary files are often faster and have like more and are more compact. But I feel like for beginners, text files are easier to understand, and that is why, in my example, I used the text file. And then, just to understand a little bit about the file flow, let's just review the process completely, step by step. First, the program creates a student subject. Second, like, the object is filled with data. Third, the program creates an output file stream. Fourth, the program writes the data into the file. Fifth, the file is closed. And then at this point, the information is permanently stored. Then the second part begins, which is the sixth part. The program opens the file again using an input file stream. Seventh, the program reads the data from the file. And eighth, the data is stored inside another student's object. Finally, what the program does is it displays the data on the screen. And this entire process, we demonstrate file writing, file reading, streams, and serialization. Thank you for watching.